So now it's time to look at problem 6.2 and 6.3. I'll save some for you guys to do on your own. Don't worry, I won't do it all for you, but I'll do a little bit for you to get you started because this stuff is tricky. Absolute values are definitely tricky. So let's look at them here. And if you remember from the last video, the whole trick of absolute values is to get rid of them. Okay, because how do you do math with absolute values? To figure out what domain of x's you need the absolute value, and then you just make it negative so you don't need it, and then what range of x's do you not need the absolute value? It's always positive anyway, so you don't have to worry about it. Okay, so let's look at b here. Well, I'll do b, then I'll leave a and c for you guys. From 6.2, so it says for each of the following functions, graph f of x and g of x is the absolute value of f of x. Okay, so we're defining this new function g to be the absolute value of f of x. So g is never negative, right? When f of x gets negative, this just makes it positive. We just get rid of the negative part. As soon as it goes below the x-axis, oh, nope, we're going to make it go above the x-axis. All right, so I'm going to do f of x equals 2x minus 5. Okay, this is b. And then you guys can do a and c. It's the same thing. So let me turn this off. All right, so first they say to graph it, and then, okay, what do they say to do? Graph it and give the multi-part rule. Okay, so give the multi-part rule looks like this. We're going to say g of x. G of x is equal to this or that. Okay, that's going to be the idea. That's the two-part. This part, whenever you have absolute values, the rule is two parts. When do you need to make it the x negative, and when you can leave it on its own. Okay. All right, so how do we graph this? So this is easy. We have and again, just make really simple graphs. Don't waste a lot of time. It's the idea here that counts. You don't need decimals or anything. Just quickly do it. So it's the x-axis and the y-axis and -5, right? When x equals 0, it's -5. So let's say that's down here. And then it's got a slope of 2. So this looks like a slope of 1, so about half that. So the slope of 2 looks like this, and then it goes like that. Okay, that is what f of x is, right? That's f of x. So this here is f of x, but we want g of x. We want the absolute value. So as soon as it goes negative, oh, no, we're going to go back up. So actually, g of x is going to be my green one here. So it just, as soon as it goes negative, the same slope, but it goes back up. Looks like that. Okay, so it's instead of -5, it hits +5. This was -5. We're going to hit +5 there. So g of x is this green one here. So I should erase that right on top of it. So this is g of x. You just do f of x, and then as soon as it goes negative, so nope, you bounce back up and you go positive. Okay, that's pretty easy. You get a graphing part. Now let's find the multi-part rule. To do that, we got to figure out first, when is this 0? And when we know it's 0, then we figure out, okay, when is it negative, when is it positive? So first we got to figure out when this is 0, right? When it's right there. We got to find that point, and then the negative part we're going to make positive. So for all this, we've got to find that point, so this part we make positive. This part we don't need to make it positive, it already is. But this part we need to make it positive. Okay, so when is 2x minus 5 equals 0? Again, that's not hard math. You said 2x minus 5 equal to 0, put the 5 over there, 2x is equal to 5, x is equal to 5 halves. If you don't like fractions, that's 2.5. So that point there is 2.5, that point there. So when x is greater than 2.5, so here's the way you do it. You say g of x is equal to, and you put a big bracket like that. We want to look like what the book has. And then when g of x is bigger than 2.5, we don't need the absolute value. It's just the regular old function. It's just 2x minus 5. And then you say here, this is for x greater than or equal to 2.5. Now, do you put the greater than or equal here, the equal here, or the equal here? And it doesn't matter. You have your choice. Which one do you want it to be equal at? Do you want it to be equal for the positive one or equal for the negative one? It doesn't matter. You got to have it somewhere. I always put it first to get it out of the way, right? So when x is greater than or equal to 2.5, we just have the regular function. When it's less than that, then we have the negative of this. Okay, so all you got to do is say negative 2x minus 5 when x is, and I like doing it this way, I don't know, when x is less than 2.5. Again, you can't put equals in either one. It can only be one or the other. Okay, so when x is less than 2.5, this is negative. So we make it negative to make it positive. Now, this is always positive, and this is always positive, because when this is negative, our negative sign made it positive. Now, that's a bad way to write it, negative 2x minus 5. I mean, come on, who does that? So I'm going to make that, really the best way to write it is negative 2x plus 5. Right? Or it's kind of weird to have a negative and a positive. We might as well put 5 minus 2x. Okay, all of them are right. This is just not a nice way to write it, but it gives you the idea, right? 2.5 is where it switches over. That's where we have to force it to be negative, because it's going to be negative. Okay, so that's how you do it. So the multi-part rule looks like this. You have two parts to it. Again, the regular part where you don't need the absolute value sign, and then when you need the absolute value sign, make it negative, so you don't need the absolute value sign. I think I've said that enough now. Okay, let's look at number 6.3. Let's look at, let's do B again for 6.3. Okay, so B, this is 6.3b, and here they give us the multi-part function, and we want to solve it for x. Kind of they give us a multi-part function. So here's what they say. They want f of x to be 1.5, where f of x is defined by this multi-part rule is 2x when x is less than 3, and it is 4 minus x when x is greater than or equal to 3. Okay, so when is it equal to 1.5 with those two things? All right, so we want this thing to be 1.5. So we just set each of these equal to 1.5. How easy is that, right? Each of them equal to 1.5. So we said, okay, when is 2x equal to 1.5? So step 1, I'll put a 1 here. You go 2x equals 1.5. Divide both sides by 2. Let's see, 1.5 divided by 2 is 0.75, right? Yeah, so x is equal to 0.75. Okay, so that's one solution. We might have more than one solution. Now, really, really important. Everybody listening? Really important. Make sure that this x is in the range. It's 2x when x is less than 3. Is x less than 3? Oh, it is less than 3. So this works. This is an answer. Okay, it's 2x when x is less than 3. X 0.75 is less than 3. It's an answer. If we had gotten like 4.75 there, even though it might have worked, you'd say, oh, wait, that's not an answer because it's not less than 3. It has to fit in the domain. Okay, let's see if the next one works. So for part 2, when is 4 minus x equal to 1.5? So let's see. Let's put the subtract 4. No, let's put the x over here and the 1.5 over there. Okay, 4 minus 1.5 is 2.5. 2.5 equals x. Does that make sense? Yeah, of course. 4 minus 2.5 is 1.5. Is 2.5 greater than or equal to 3? Right? This formula is only good when x is greater than or equal to 3. But here x is 2.5. That's not greater than or equal to 3. So this is not a solution. It has to fit in this range. If the answer you get is not in the domain, I keep saying range, but it's domain when you talk about the x values, then it doesn't work. So this is our only answer. Even though we got this answer, it doesn't work. This is the only answer that makes it work. Okay, that's the tricky part. I was still hoping for an absolute value one because I want to do more stuff. So let's look at A. What the heck? So A says g of x is 17, where g of x equals absolute value of 3x plus 5. Okay, so erase this stuff here. So this is 6.3b. So 6.3b. And again, it says that, what does it say? It says f of x, we want, when is f of x equal 1.5? Sorry, I want to do a, not b. I want to do an absolute value one. 6.2a. So 6.2a says, blah, it's all over again. G of x equals 17 where g of x is equal to, so here's our multiplier. We want to know when is it 17, and this is the function here. G of x, oh man, here, I'll do this up here. Where g of x is equal to the absolute value, that's the whole point, I want to get absolute value, 3 of x plus 5. So this is how we define g of x. We want to know when g of x is 17. Now we could graph it and see when it's 17. That would be a totally good thing to do. But let's just do this algebraically. Let's break this up. Here, actually, this is premature. To solve this, to solve absolute values, you get rid of them. You make a multi-part function. So to do that, you got to know when it's 0, when it crosses over from negative to positive, or positive to negative. That always happens when it's 0, right? That's how you get from positive to negative. So we got to know when this is 0. So the first thing we do is we set 3x plus 5 equal to 0. We find the crossover point from negative to positive, so 3x is equal to negative 5, x is equal to negative 5/3. I did that right? Put the 5 and the 5. Okay, that's ugly. Well, now let's just leave it as negative 5/3. So negative 5/3 is a crossover point. Now, when x is less than negative 5/3, when x is less than negative 5/3, then 3 times the number, big negative number, this is going to be negative, right? When x is equal to 5/3, it's negative 15 over 3, which is negative 5. When x is more negative, like negative 6/3, negative 2, this is going to be negative. So then our function is negative of 3x plus 5, because this is always negative when x is less than negative 5/3. So we make it negative to make it positive. Now, when x is greater than or equal to 5/3, negative 5/3, then we don't need the absolute value sign. It's always positive. So we can just write 3x plus 5. Okay? Now, I'm just kind of figuring it out here. A better way to do this is to write, or we could do this. Let me say, okay, so our new function, g of x, a different way to write it is like this. Absolute value of 3x plus 5 is exactly the same thing as negative 3x plus 5 when x is less than 5/3, 3x plus 5 when x is greater than or equal to negative 5/3. Normally, I would have put the positive one on the top, but it doesn't matter. Right? I was just kind of doing this. Okay, now to solve for when it's 17, we set each one equal to 17 and see what we get. Right? We set each one equal to 17 and see what we get. So that's the third part of this problem. So I'm going to do this in, I'll do this over here, so hopefully everybody got all that down. So we set each one to 17, and then, very important part, we make sure it works, because maybe it won't even work. So that's the tricky part. Okay, so let's do this first one. So when does negative 3x plus 5, right, when does that equal to 17? Well, let's see, that's negative 3x minus 5 equals 17. Negative 3x equals, add 5 to both sides, 22. X is equal to 22 divided by, that's ugly. I did that right? 22, shoot. So negative 22 divided by 3. Okay, that makes this work. It's equal to 17. But is this in the right domain? This is for x less than, right? This is for x less than negative 5/3, less than negative 1 2/3. This is definitely less than negative 1. This is like negative 7 1/3. It's definitely less than negative 5/3. So that's an answer. That is one solution where g of x is 17. Now let's try this one. 3x plus 5 is equal to 17. 3x is equal to, subtract 5, 12. Oh, I like this math. X is equal to 4. Is 4 greater than or equal to negative 5/3? Well, yeah, it's positive, so it's greater than or equal to negative 5/3. So that is an answer too. So in this case, we do have two answers. Both of them work. Again, sometimes one of them doesn't work. Sometimes both of them don't work. There is no solution. But always check again that it fits in the domain. So for 6.3a, again, there's two answers. And the whole point again of absolute values is you figure out when it's 0, when is it 0, and then you know when it's negative, you make it negative, then you don't need the absolute value sign. And then when it's positive, you don't need the absolute value sign because it's positive already. So it's always a two-part, multi-part function. Two-part function. Okay, I think I've beaten that enough into the ground, or some dead horses, or something like that. All right, very good. Adios.